Welcome to my channel Simple Concepts by DJ. Today we are going to see the AC circuit. Okay, the AC circuit. Here in this AC circuit we are going to consider in that we are going to attach one element, that is one resistor element, and we are going to observe how the values of current as well as voltage as well as the power is going to react when we connect a resistive element that is in series with a AC source. So let's get started with this one. So this is the topic is called as AC through alternating current through pure resistor value. Okay, so the circuit diagram will be like this. See, this is the resistor value. This is the resistor value, and I am connecting a AC source. This is an AC source. Okay, AC source, which is nothing but as I'm applying a sinusoidal voltage here. So this will be plus and this one will be minus, which is connected with the resistor. So I'm naming the resistor value as capital R. And this is the AC voltage source. So when I connect this AC voltage source with this resistor, a current will flow. So I am naming the current as small letter I. See, I is the value. Okay, this is the current will go through the resistor and it will come to the negative terminal of the AC voltage source. So it will be minus, it will be I, right? So a voltage will be developed across the resistor, that is VR. Okay, so this current will go like this. So a current will move through this loop. Okay, so now what are we going to do is, let us assume the applied voltage. I am representing the applied voltage using a small letter V. V equal to capital VM into sine of omega t. So V is the applied voltage, and the equation of that applied voltage, the value of the applied voltage will be Vm into sine omega t, where Vm is the maximum voltage that has been developed in the circuit. So what I'm going to do is, this is V equal to Vm sine omega t, right? So now I have got this equation. So the applied voltage, getting into the derivation part, is the applied voltage. The applied voltage small v will be capital Vm into sine of theta. Okay, theta is the angle between the current vector and the voltage vector. Here in this AC circuit, when it is connected across the resistor, the wave diagram will be like this. This is the wave diagram. Here, this is a complete 360 degree wave, and this is called as the voltage. Let us assume that this is the voltage wave. I am representing this as a voltage wave. And how will the current be when you connect only a resistive element in the circuit? If you connect only the resistive element in the circuit, the current will also be in phase with the voltage. This will also be in phase with the voltage. What does it mean by being phase with the voltage? Being in phase with the voltage means the current and the voltage will start at the same instant of time at zero. They will reach the maximum peak level in the positive direction at the same interval of time. Again, they will drop and fall to zero. Again, they will reach their peak in the negative direction, and again they will reach the x-axis line. They will fall to zero. So this is what the current wave looks like. See, this is the current wave. So I am naming this one as I. Okay, I equal to Im into sine omega t, and similarly this will be equal to Vm into sine omega t. Okay, so this is the voltage wave and this is the current wave. See, both the voltage wave and the current wave are in phase with each other. So there won't be any angle formed between the voltage vector as well as the current vector. So that is what this wave diagram depicts. Okay, so the applied voltage V equal to Vm into sine theta. We know that theta equal to omega into t. This is the formula for finding the value of theta is omega into t, where omega is the angular velocity and t is the time period, right? So what I'm going to do is I'm going to write Vm into sine of theta is, instead of theta I'm going to substitute it with omega t. V equal to Vm sine omega t, right? So according to Ohm's law, I know that V, small v equal to I into R. So V is the applied voltage is equal to the product of the current that is developed in, and the product of the current that is the product of the current that is being developed in the circuit and the resistor value, the pure ohmic resistance, which is nothing but capital R, V equal to I into R. So this V equal to Vm sine omega t and V equal to IR, both have the same value. So both are being represented by the same parameter, voltage parameter. So I'm equating both the things. So if I equate it, I'll be getting I into R equal to Vm, which is the maximum voltage, into sine of omega t. So now I can get the value of I equal to Vm divided by R into sine omega t. So this is the value of current. Okay, that is moving, that is looping around this circuit. So I have found the value of current I equal to Vm by R into sine omega t. Okay, so now what I'm going to do is I equal to Vm by R. What is Vm by R? I equal to V by R. I equal to Vm by R. So can I write Im equal to Vm by R? Because in this expression you are having the maximum voltage. So now if you have the maximum voltage, the current will also be maximum as per the wave diagram. Similarly, when the current voltage reaches a 0 point, the current also will be 0. And again in the negative direction, if the voltage reaches the maximum point, the current also will be reaching the maximum point, okay, on its own path. So since this voltage in this equation, voltage has reached the maximum value, similarly the current which is equated to this ratio will also reach the maximum value. So Im is equal to Vm by R. So what I can do is I equal to Im, I can substitute Im instead of Vm by R. That is Im into sine of omega t. So I got the value of I. Okay, this is I equal to Im into sine omega t. So what I can do is, for example, if sine omega t is unity is 1. Okay, so if sine omega t takes the value of 1, then I equal to Im. When sine omega t becomes unity, then I is equal to Im, which means that the instantaneous value of current which is looping around this circuit is nothing but the maximum current that is being obtained. I equal to the maximum current. I is equal to Im. So now what I'm going to do is, I have this one, this is the voltage equation, and this one is the current equation. So voltage equation I have got the current equation number 2. Okay, I have two different types of equation. So I have found the value of voltage here, I found the value of current here. So the pattern remains the same. See, V equal to Vm sine omega t, I equal to Im sine omega t. From the equation itself, they are more or less, they are very identical. So why they are identical means because these voltage and current are in phase with each other as depicted from this wave diagram. So now what we are going to find is we are going to study about the power that is being developed in this circuit. Yeah, the camera holds on. So what is power actually? For finding the power, what we need to do is, see, power is equal to, so we know that power equal to the average power. Power is equal to voltage into current. Voltage into current. I'm taking the small letter V and small letter I. Small letter V into small letter I. That is power. Product of voltage into current is nothing but power. Power is equal to voltage into current. So we know the value of small v. Small v is nothing but Vm sine omega t, which is Vm into sine omega t into what is I? The value of I is Im sine omega t. It will be Im into sine of omega t. So that will be equal to Vm into Im into sine omega t into sine omega t will be sine squared omega t. So that will be sine squared omega t. So sine squared omega t. So this is the value which we are getting, sine squared omega t, right? Omega t. So now what we need to do is sine squared omega t. How to find the value of sine squared omega t? We know that cos of 2 into omega t is nothing but cos squared omega t minus sine squared omega t, sine squared into omega t. So this is the formula. So cos squared omega t can be written as, we know, sine squared omega t plus cos squared omega t is equal to 1. So cos squared omega t is nothing but 1 minus sine squared omega t. So which is equal to 1 minus sine squared omega t, okay, minus sine squared omega t, sine squared omega t. So now what I'm going to do is, which is equal to 1 minus sine squared omega t and minus sine squared omega t, which is nothing but minus 2 into sine squared omega t. So I got 1 minus 2 sine squared omega t, which is nothing but cos 2 into omega t. So now what I'm going to do is, I'm going to bring this minus 2 sine squared omega t to the left hand side. So it will be 2 into sine squared omega t. 2 into sine squared omega t is equal to 1 minus cos 2 omega t. When it is taken to the right hand side will be minus cos 2 omega t. Minus of cos 2 into omega t. So now sine squared omega t will be sine squared omega t is equal to 1 minus cos of 2 into omega t divided by 2. This is the value. This is the value for sine squared omega t. So I am going to substitute this value in place of sine squared omega t. So that will be, so taking this power value here, power is equal to Vm into Im into sine squared omega t, sine squared omega t. So we have found the value of sine squared omega t. So I am substituting it over here. Vm into Im into sine squared omega t is 1 minus cos 2 omega t divided by 2. Divided by 2. Therefore, I am multiplying this product of Vm Im with these individual terms which is inside this bracket. So it will be Vm Im divided by 2 minus Vm Im divided by 2 into cos of 2 into omega t. here omega, what is omega? Omega can be written as 2 pi by t. So 2 pi by t can also be written as 2 pi into nu. Nu is nothing but the frequency that has been developed in the circuit when the alternating EMF has been connected. So this frequency is being connected with this omega. So omega also contains the frequency. So this frequency which is developed will be double. The value will be double when compared to the value of the voltage and current that is produced in this circuit. The frequency have a double value. So that is what cos into 2 omega t, right? So for a complete cycle, the average power for a complete cycle will be 0. Okay, so this cos 2 omega t Vm Im by 2 into cos 2 omega t will be 0. Okay, this total quantity will be 0. So if it is at 0 means we will be left out with P equal to Vm into Im divided by 2. Okay, so I can also write it this as equal to, see this portion is 0. Okay, so Vm Im divided by 2 can be written as Vm into Im divided by 2 can be written as root 2 into root 2. So it will be root 2 into root 2, which is equal to Vm divided by root 2 into Im divided by root 2, which is nothing but, what is Vm by root 2 and Im by root 2? It is nothing but capital V. V is equal to Vm by root 2. Similarly, I equal to Im by root 2. So which is V into I. This is expressed in watts. Okay, so the power that is being developed is nothing but the product of voltage into current that is being developed in watts. So in a resistive circuit, in only a resistive circuit, the power won't be 0. Okay, the power will be having a value. Why means, because the instantaneous value of current and the instantaneous value of voltage will be either both will be negative or both will be positive. So if both are negative means minus into minus will be plus. And similarly, if both the instantaneous value of current as well as voltage is positive, plus into plus is plus, so they will be getting a positive value. So the power will be always be a positive quantity. Okay, so this is all about this equation. So we have derived the derivation that is coming under the heading as AC through pure ohmic resistance alone, right? So that is the end of this derivation. Thank you all for watching this video. I hope this video will be useful and very much interesting to you. Please do subscribe. Thank you all.